All right, now we are going to go through the last topic that we weren't able to do in class. This is called the Leslie matrix, and it has some sort of differences of what we are going to expect from this matrix. The whole form, the elements have certain characteristics, so we are going to go through the whole understanding of the how to interpret the Leslie matrix and when are we going to use it. We are going to do a couple of examples, and we are going to do also the one that it was done last year in the sample exam. All right, here we go. So we use the Leslie matrix um, to talk about population growth. Okay, now they are particularly useful in this model to change the changes between particular age group in population. So in these matrices, when they talk about Leslie, they bring age groups in between. All right, so that's how you know that they're going to talk about Leslie matrix when they talk about age groups. In the Leslie matrix, we are interested in two things, and I encourage you to highlight it. The first one is birth rates, and the other one is survival rate. Super important, those two, because those will be represented in the matrix. In this model, a population of a certain species is divided into age groups, as we said, and the model uses birth rates and survival rates with those age groups to describe the growth of female population of a species over time. Now, they say here female population because female is the only one that can reproduce offspring. All right, so that's why they've mentioned mainly the female. Now, the form of the Leslie matrix is kind of like that. This is obviously written to the infinity number, but the characteristic, like the main characteristic, is that it's a square matrix. And the first row, it's super important. The first row would be the birth rate. Okay, the first row would be the birth rate, and the second, if you look at the second row and the numbers underneath, so this is what we call again the leading diagonal, but this is the second kind of like another leading diagonal underneath the leading diagonal, and it's going to go like this, yeah, this way, and these S represent the survival rate, and it's going to be written in that leading diagonal form. Okay, super important that we understand that, how to write it down. So survival rate, those are the values that it will go in these two spaces. The rest of the matrix is full of zeros, so the only values that we are going to populate or they will be given in our Leslie matrix will be birth rate and the survival rate. Again, with F, it's the birth rate, and S is the survival rate for a particular age group. So this is divided in age groups. Okay, we will do an example and then you will see what I'm saying. This is from your textbook, a Leslie matrix. We can do again a recurrence relation to see the pattern of, it's like another form of transition matrix, what happens from one year to the next. So to find the next state matrix, in a way, it's the Leslie matrix times the one before. Well, L is the Leslie matrix, and SO, S naught, is the initial state matrix. To find the first one, well, I'll bring back the 0, 1, and if I continue like that, I will kind of like complete the sequence. So that S2 will be the Leslie matrix times S1, and so on. So in other words, if I want to find the nth number for a particular year or a particular iteration, I basically just take the Leslie matrix and raise it for the number. I raise it to the number that I'm looking for, and then I multiply by the initial state matrix. Now, super important here that I encourage you to highlight, the Leslie matrix is a square matrix. Again, that's concepts important in our exam, that has the same number of rows and same as the population has age groups. So look at this. That has the same number of rows and columns as the population has age groups. So if I have 4 different age groups, it would be a 4 by 4. If I have 3 different age groups, I will have a 3 by 3. They will tell you the number of age groups, and that will be the number of the order of your matrix. S naught is the column matrix containing the initial population for each group of the species. All right. Again, the first row is your birth rate. This number underneath the leading diagonal in the form of a diagonal is the survival rate. All right. Now this is from your textbook, and then we're going to do another example from your textbook, and then we finish with one from the exam. Consider the following information gathered about a population of female. I was going to bring this female rabbits in a closed environment, one with no migration. The birth rate, so important here, is the average percentage of offspring born to that age group. The survival rate is the average percentage of rabbits that survive to the next age. The assumption of this model is that there no rabbits live beyond 3 years. All right, and they give me this. So the age group from 0 to 1, from 1 to 2, from 1 to 3. The number of rabbits that between 0 to 1 are 80 rabbits, from 1 to 2 are 40 rabbits, from 2 to 3 are 60 rabbits. Now here, the birth rate of this age group is 0.32. So they can populate at a birth rate of 0.32, I guess. Similarly here, the age group is 1 to 2, and this birth rate has this population at this number of years have a birth rate of 1.3, and 2 to 3 have a birth rate of 0.6. The survival rate of the first age group is 0.45. The survival rate of age group 1 to 2 is 0.77, and then here they just died from 2 to 3. There's no much of a survival rate, and also because it says that no rabbits live beyond 3 years, right? The survival rate is very small. For the information about the information about the rabbit population provided in the table above, the recurrence relation can be given by this information. Now I want you to notice this. These values are the first row, are my birth rates. Yep. And notice then after, these ones here are my survival ones. Okay. Super important. And then the rest, actually I need to do it better. And then the rest is populated by zeros. Now, how do I know that it's a 3 by 3? Because I only got 3 age groups. So the number of age groups will tell me how many columns and rows we'll have. And the state matrix, the initial state matrix, they give it to me here in this scenario. Yeah, and it normally is a column matrix. The first row of the last image contains the birth rates of each group. That's pretty much, this is basically what this part. So this is the birth rate. So if I rewrite this part here, this is 0 to 1, 1 to less than 2, and 2 to less than 3. Okay. And that's basically how we interpret that Leslie matrix. Now, the population of rabbits in n amount of years, well, it's this formula, the transition times the number of years times to the power of n, the number of years times the initial matrix. If they ask me to find the population of rabbits after 5 years, so it's the transition matrix to the power of 5 times the initial matrix, and there you go. Now, you might be asking, what are those values? So the initial value, this one is the number of rabbits after from 0 to 1, the number of rabbits from 1 to 2, and the number of rabbits from 2 to 3. All right. Those are the numbers after 5 years. That's what it says. Cool. And if I want to find out the number, so there are approximately 180 female rabbits after 5 years. How do they know that? Because they add all these numbers together. And that's what basically is a Leslie matrix. It just collects information, but now it's related to population growth, and then we bring birth rate and survival rate. How do we interpret it? Well, the first row is the birth rate, then we have the leading diagonal and the numbers underneath that, and in the form of a diagonal, the survival rate. All right, here we go. Let's do a question. An agriculturalist is studying the breeding and life cycle of hens in a breeding program. The hens have a 3-stage life cycle. So we got eggs, chicken, and adults. So I'm assuming that they will be the 3 age groups. Only adults female reproduce. Again, yes, it's only the female. And it says here producing on average 550 eggs in lifetime. Okay. The agriculturalist research has determined that on average 0.72% of eggs survive to be chicken and 55 of chickens survive to adulthood. If this program has no adults, 20 eggs and 15 chickens at the start of the study. Okay, so this information is actually super important. It will be my initial state of the matrix. Use a Leslie matrix to model. Use the Leslie matrix model to determine the initial state, the Leslie matrix, and the number of adults after 4 cycles. All right, let's start with question A, which is finding the initial state. Now, here is my initial state is in this sentence here. It says here, if this program has no adults, so adults will be 0, but we got 20 eggs and 15 chickens, and eggs, chickens, and adults, and that's my initial state matrix. All right, now what is my Leslie matrix? Now, what will be the order of this Leslie matrix? I've got 3 stages in life cycle: eggs, chicken, and adults. So that's what is going to be my order, 3 by 3. Okay, and eggs, chicken, and adults. Okay, now what do we write? Now on the first row, we are going to write the birth rate. Now, the only ones that can, in a way, produce offspring are not the eggs, neither the chicken, but the adult chickens. It says the adult females reproduce, not the chickens, the adult females. So in this case here it says on average 500 eggs in lifetime produced by the adult females. So that would be 500 here. Now it says the agriculturalist research has determined that on average 72% of eggs, okay, so 72% of the eggs survive to be chicken. Okay, and look what we said. So this will be 0 and 0, and the one underneath the leading diagonal, so I've got the leading diagonal here, and the one that underneath that would be my my first survival rate, which is 0.72, and look what it says. It makes sense. 72% of eggs, yes, survive to be chicken. Survive. This is chicken. 72% of eggs survive to be chicken. That makes sense. And then the next one, it says 55% of chicken. All right. So 55% of chicken. 55% of chicken survive to be adult, and the rest of my matrix would be 0. All right, there you go. That will be your Leslie matrix. Again, here I have my, what did I put in blue? Blue is my birth. Here is my birth rate, and here is my survival rate. See, we have the number of adults after 4 cycles. So S4 would be my Leslie matrix to the power 4 times S naught. So 0, 0, 500, 0 0.72, 0, 0, 0 0.55, 0 to the power 4 times my initial matrix, which is 20, 15, and 0. And that would be the number of adults. All right, so we have to look at the adults. That when you do it in your calculator, after 4 years is 0, 3136.32, and 1796.85. Now, which ones are the adults? Well, the adults are these ones. The number of adults after 4 years is 1796.85 adult chickens. All right, does that make sense? I hope that it does. If not, go back and watch it again, because again, it's not as complex as it looks like. It's very straightforward. Now, this is a question from the sample exam 2023. Let's do it, and then you will have an idea what to expect for your exam this year. It says the sanctuary monitors to breeding sanctuary monitors the breeding pattern of the female production of a species of marsupials on a nearby island. The marsupials have a lifetime span of 12 years and have been categorized into 4 age groups: 0 to 3 years, 3 to 6, 6 to 9, and 9 to 12. Also, they have a lifespan only up to 12 years. All right, cool. The Leslie matrix that models the breeding pattern for this female monstrous population is the following. All right, cool. Remember, this is my birth rate, and this is my survival rate. Don't forget that. And then the rest is zeros. The same information of these metrics can be written in this diagram. Yep. All right, let's write it. Let's see it. We go to three, 4 age groups. Yeah, 1, 2, 3, 4. And then we'll see the information. I will probably do this for my own sake. This is 0 to 3. This is 3 to 6. This is 6 to 9. This is 9 to 12. And same for here. 3 to 6, 6 to 9, 9 to 12. All right, so I'm going to represent, I'm just trying to understand the diagram as well. Now it says here that the ones that they were at the start from 0 to 3, they survive 0.5 to 3 to 6. Beautiful. They move to 3 to 6. Now from the ones that went 3 to 6, 1.4 survive at an age 0 to 3, and 0.5 survive the next age group. Okay, and then it got beyond that. And for the next one, which is 6 to 9, 1.6 survive the first age group, 1.6 survive and 0 to 3, and 0.2 survive the last age group, which is 9 to 12. Now notice that there's nothing here, because at this time it says the marsupials have a lifespan of 12 years. So 9 to 12, probably there's no birth rate because they're obviously about to die, and there is no transition to any of these other age groups. Awesome. Here, the following table shows the birth rate for each of the following age groups: the average population, the offspring born on each group, and the survival rate, the average proportion of offspring to survive to the next age group. Some values in the table are missing. All right, let's do it. The birth rate. I'm missing the 0 to 3 and 6 to 9. Well, 0 to 3 would be 0 because it's this one here. Ooh, let me see if I can zoom out. It's this one here. Yep. And 6 to 9 would be 1.6. Okay. Now, the survival rate. Now, I've got my first one, which is 0 to 3, is 0.5. 3 to 6 is also 0.5. And 6 to 9 is 0.2. Yeah, I'm following this. And it follows the same order on here. All right. Awesome. Then the initial state matrix for this female marsupial population can be written as follow. Okay, so there are 20. It's important to know what is this. This is 0 to 3, 20, 0 to 3, 3 to 6, 6 to 9, 9 to 12. That's the number of marsupials at those age groups. The recurrence relation to model the breeding pattern of this marsupial population is as follows. By calculating S1, determine how many marsupials there are aged 0 to 3 years after 1 3-year time. All right, it says after 1. Now, do not get confused with this. After 1, technically it's after 1 year. This 3-year time is the 3-year period. 0 to 3 are 3 years. So after 1 3-year time. Okay, very simple. So it's the Leslie times your initial, and that will give you this. And because they asked me the 0 to 3 is 136, and remember you have to write down 136 marsupials 0 to 3. Yes. Now this question had a little bit of a misinterpretation because of the wording. Let's see what happens here. What percentage of this female marsupials population are age? So now they ask me what percent are age of only this one. After the second, so similar or what happened? Similar here, second, and here is 3 years. So the second, and then they ask me obviously this 3 interval of years. So they asking me as to what is the age group, but be careful, is the percentage of this female after the second 3-year period, and then we have to round it out to 1 decimal place. All right, so it's more than just giving the number. We have to find the percentage of these ones in the second year. All right, let's do it. So it's simple. Now S2, again the transition matrix. Now you bring this one down here, or you can either do the transition to the power of 2 times the initial matrix. It gives you the same solution, and this will be the solution. All right, now remember my last value is 9 to 12, and the answer is not 4. That's what many people wrote in this answer. They're asking you the percentage. So what is the percentage of this female? So you have to, in a way, go back and add up the total number of marsupials in the initial state, which is 125. So 125 at the start, I added all these numbers here, all these numbers. I added all these numbers, and they gave me 125 marsupials at the start. And I want to see what is the percentage in the second year. Well, it's 4. So 4 divided by 125, it would be 3.2% of marsupial age 9 to 12 in the second year. All right. All right, guys. Well, that's all. That's everything. I hope hope that this have helped you, and please go back if you need to revise and take notes on your summary book. If you have any questions, please, yeah, send me an email. Take care, guys.